Hi guys, welcome to Learning Electronics Repair. I have an old motherboard here. This is a Pentium 3 board. They're actually quite valuable, these, on the retro scene. We had a look at this on one of the car boot videos. And this board will not start. The reason for that is quite obvious, because this chip, the SIO chip, which is involved in the startup, is getting very hot. I'll just show you that again, and then let's see if the problem could be the voltage supply to here is too high, or B, it's just a faulty chip, and we can see whether replacing that fixes it. I mean, there are other possibilities, like there's something else around here causing that to get hot, some sort of short or something. But with so many pins to go at, I think probably if we're happy we have the right supply voltage, then we should just try and change it. I have the thermal camera. You can see at the moment the motherboard is powered off, so it's just cold, yeah, nothing happening much. I'll switch on, so we're just going on to standby now. I'm not trying to start the board. Let's see what happens. And there you go, straight away, so you can see the centre of that is 70 odd degrees. Okay. That chip is very warm, and that's just with the standby supply on the 5 volts. I am not trying to start the board. So this chip is definitely getting very hot. Let's have a look at the data sheet to see what power supply rails the chip needs. Well, here we have the data sheet for IT8712F, and if we scroll down a little bit, we can find the pins that we're interested in. I always like this page intentionally left blank, but by printing that, surely it actually isn't left blank. Yeah, you kind of like defeating your own argument there, don't you think? So here is the pinout after worrying about that too much. We have VCC, VCC, VCCH and VBAT. So those are the supply voltages, and if we look a little bit further down, here are the supply voltages. So you can see VCC and VCCH, which says power and help supply, whatever it means by help. They have 5 volts, and our power supply is in standby, so the only voltage it can be providing is 5 volts. We have the 3.3 volt battery supply. Well, we know full well the battery is 3.3 volts, and we have this one, voltage ID power supply, 1.2 or 3.3. So we could have a look on pin 36 just to see if that is actually higher than 3.3, but I wouldn't be surprised if this supply isn't there at all at the moment. This quite possibly comes on when you start the board, because the voltage ID, this effectively comes out of the CPU. Having said that, we can have a look at pin 36, and if we're happy with that, then we can change this chip. The other ones, they can't really be any higher than that, because the power supply is a known good one, and we know the 5 volts standby is 5 volts. Pin 1 on the chip is the one marked here with a chevron on the corner, if you like, a slanted corner. So we can see from the bottom end of here, 36 is the 3rd pin in on that corner, so we can check that one. Let's look. So this is the pin. I already have my meter probe on it. It's not powered on at the moment, but I won't slip from there now, so I'm going to switch this on and then just put the other lead onto ground, which is easy. And what do we have? Well, we have practically nothing. That's what I kind of thought we would have. The next one up actually is VCC. I've switched it off again. Let's just go for it. So that is that. So that's VCC. Again, I'm safely on it. Switch on. And that's reading 1.19. And the reason it's reading low is because this is dragging that power down. It's coming through a MOSFET or something on the way, or a resistor, and it's dragging it down due to the fact it's drawing a lot more power than it should. Let's take this chip off the board and let's see what happens there. We'll try and replace it. The replacement one I have is actually a pull. It's there, you can see it. It's the same chip. The legs are a little bit higgledy-piggledy, so that'll be a bit of fun soldering it, but we'll figure out how to do that as we go along. And then I must admit I don't actually know if this chip is actually a good one or not, but I'm kind of hoping it is, so let's see what happens. There are a few ways of desoldering these. Some people just prefer to use hot air as it stands. I prefer to get some fresh leaded solder on all the pins first and then use hot air, because by mixing the leaded solder I reduce the melting point, so I should be able to get this thing to desolder before any of the surrounding components, which are unleaded solder, actually melt. Yeah, not the component, the solder of course. And I find that easier because then I don't have to worry about putting Kapton tape around here, which basically just makes it more difficult to get heat into the board anyway. There's nothing too close to this one, so I don't see any problem with adding the leaded solder. One problem can be that when you lift this up, you might accidentally take something with it. I would suggest you take a photograph, or as I'm doing, I'm actually videoing this so that once I've removed it, I can compare it just to make sure everything is still in place. I'll get this under the microscope, the optical microscope. It's much easier for me with the stereoscopic vision. And let's see if I can do this without making myself look stupid. Yeah, let's have a go. I'm sure you've noticed that looks a little bit strange on the camera. That's because I'm using the capture card, which basically thinks the image is going to be 16:9, and on my camera it's actually giving me a 4:3 image. That's why that is, but it looks perfectly fine when I look down at the microscope at least. Okay, so I'm not going to worry too much about that. I'll just add some flux. And then I'm just going to put leaded solder all around the chip. This will probably bridge all the pins together. I really don't mind that at all. In fact, that'll probably make it easier. I need to get in here a little bit awkward here. If I melt this little pin head, I'm not bothered. I mean, I can soon fit a new one of those on there, so not too worried. In fact, the hot air will probably cause this to melt anyway. I could have taken it off, but I've got pin headers. On this side, so you see I'm getting leaded solder on, it's bridging a lot of the pins. That'll just assist the heat basically. Okay, it's difficult for me to get the hot air in under the microscope, so I'm now going to use the overhead bench magnification. I've removed the RAM, I've removed the CPU, the heatsink. I'll try and direct the hot air in from this direction so as not to melt the CPU socket, of course. As I mentioned, I'm not too worried about that pin header, but I'll try not to melt it. I'm going to use some sharp tweezers to get under the edge of the chip, so I should be able to lift this from one corner, whichever is the easiest one to get at. Maybe that one. Because I'm right-handed, I'll use the tweezers in my right hand and I will hold the hot air in my left hand. Hot air set to 450 degrees, maximum airflow. Let's see. There's a little electrolytic capacitor just off the shot, so I'll try and keep the heat away from that as well. Okay. Well, I'm hoping that the leaded solder does the job here for us. Yeah, the camera's going to refocus by itself, can't do much about that. Okay. Nothing happening yet, really. Something didn't like that. Was actually the sticker. This thing, yeah. That's what I'm crap. Sliding now. It's off. I didn't mean to slide that so far, but sometimes that happens. You can see I have managed to dislodge one component here, so while the board's nice and warm, I can fix that. I made a right mess of that one, but I'm sure I can sort it out. I have an image of the board before. This is the problem when the thing slides. While the board's warm, I might as well try and solve a couple of these little problems. Okay, so let's see if we get this one back into place. Yeah. I was going to say I might need a bit of fresh solder to do this, but I think it's working fine with the original solder. Let's have another go. No, it's sticking to the tweezers rather than the jar. Okay. A bit of flux is going to help here. I'm now using the soldering iron with my right hand, tweezers with my left hand, just because of the angle at which I need to work. Okay, that's on there. See if we can get a little bit flatter. Looks better. Bit of solder. Okay. This one I think is okay. I think it just moves slightly to a different angle, but I'll put some fresh flux on and we can just see if we can just tidy that up a little bit as well. Probably should be using the thinner solder for this, but if I have problems I will get it. Okay. Turn the board round. Yeah, it's fine. What's happened with this other one? So there's one here that's moved. And I'm pretty sure it came from there. I can refer back to the video, but that's where I think it came from. Bit of fresh flux. Yeah, it didn't come from where it ended up. So we can get this onto here. Let me turn it around. With this sort of work, guys, you'll soon figure out that you become very good with both hands, yeah. I'll just put that there on one end for the moment. I'm just going to refer back to the video to see if that didn't come from here. Okay. Nothing else seems to be dislodged. Okay, well, I'll just refer back. Yeah, I'm correct. That does actually come from there. There was nothing here. So I'll just solder the end of this one down now. Again, I'll turn it around to make it easier to work from the angle I want to. Okay, I think there's probably enough solder on this one actually. Yeah. So that's on. This one was on anyway, just clean that a little bit. So that looks okay. That looks how it looked in the previous video. I'll just remove these blobs of solder from here and then we can clean this area up. This will just use braid. I'll put a bit of flux on the braid, that helps quite a lot. Okay, let's see. So that one, yeah. In fact, I'm going to go around and clean all these pins, get them nice and clean. You can cut a short bit of braid off if you're worried about the heat transfer up the braid, but for chips like this, really there's not big power planes around here, so you'll probably find this method actually works just fine for you. Having said that, do what you prefer and do what works well for you. The trick with this is not to drag the braid, just hit it and let it soak the solder. That way you're very unlikely to rip any pads off. Okay. Just let the braid do the job for you. Okay, we can clean that up with a bit of isopropyl. I think I might spot just one that I was a bit unhappy with. Go again here. Yeah. Okay, let's clean this up. There. With these, generally getting them off is the easy part, and the more difficult part is putting the replacement on, especially when it's a pull and the pins don't really line up properly. So you can see we have some bent pins. I'm not actually looking down the microscope, I'm just looking at the screen at the moment. But what I'm going to try and do is to tag this on with a few of the straight pins with a bit of solder just to get the thing to hold straight, and then I can go around and straighten up the remaining pins and solder them. Some people prefer to do this with hot air. I prefer to do it with a soldering iron. Again, that is just preference really, so use whichever method works for you. The important thing then, obviously, do we have the chip the right way round? So you can see the chamfered edge here, and there's actually marked like white silk screen line there. That's the corner. Again, you can just refer back to the photo. You did take one, didn't you? That's another good reason why. Because after you've rotated the board around a few times to get the correct working angle, it's not difficult to get completely confused and get the chip on the wrong way around. You can see I have this corner lined up pretty well there, and these pins are straight. So I'm probably going to stick this corner down first, and when that one's in place, we'll go for this top corner. Let's see if these pins are fairly straight. Yeah, pretty much so. So I'll try and tag these two corners down first, and then I'll start to deal with any bent pins that I see. That looks reasonably level, but I'm going to use the microscope. I'm going to get some flux on here, just on the corner where I want to work, and I'm going to use the fine solder this time. So I'm using 0.2 millimeter solder. Should be able to hold this in place fairly well. Let's have a look. So just take your time, guys, so you're happy the thing is fairly straight. I'm lucky there might be enough solder on the iron just to get this corner. Let's have a look. Yeah, it looks like I've got one pin in the corner. That's what I was after. If you get a solder bridge at this point, really don't worry about it too much. Okay, that corner is held down. Let's have a look around the other end. I'm actually going to rotate this around again just to make life easier for me. Coming from this angle, I want to get this side pinned down. Again, I have some bent pins. I'll just try and get it as best I can and then deal with that afterwards. Okay, that looks fairly straight. No, it's not on this bottom edge, that's more like it. Yeah, I think I have it there. This is fiddly work, guys, so just take your time with it. If you're not happy, just lift it and start again. Okay. Okay, as I've shown you before, guys, you don't need a fine tip soldering knife. There's a chunky one is absolutely fine. But again, use what you prefer. I prefer this because it gets it all hitting quickly. Okay, you see I have it. Right, so I've got some corners pinned down now. So what I'm going to do now is I'm going to go all the way around the chip with the end of my tweezers and just straighten all these legs so they sit in on the centre of each pad. If I can't straighten them all up, I can always desolder the thing and start again. This is the time consuming bit, guys, so I will just show you with one or two and then I'll get on with it and sort it out. So you can see this end, this is out of line. Tweezers might be too big for this, you might need something a little bit finer. Let's have a look. Well, you can see they're easy to bend. Sometimes you bend them too far. Okay, that one is lined up now. It doesn't have to be in the centre of the pad exactly. It just needs to be in place basically so it can't short to anything else. Okay, and then I'll work my way along, just doing that with all of these till I'm happy with them. Well, that side actually looks pretty good, yeah. They're all on the pads, they're not going to short against them. Okay, that side's pretty good. Let's look at this side. Yeah, this one needs a little bit of work. A few bent pins on this side. You're only going to have this problem really when the chip is a pull, unless it's been badly handled or stored. Part of the problem here, you can see the legs are actually bent outwards. Yeah, just pushing them back into place. Okay, so I have every pin sitting over a pad now. I could try drag soldering, which is effectively where I take this soldering iron, I put flux on and I just drag it all the way down the pins. But because some of these are lifted up because it's a pull, that might be a bit difficult. So I'm going to try just putting flux and just trying to solder a few pins at a time, coming in this way. Again, if I get some bridges, I can deal with them with the braid. Again, it will take some time, but I think that's the way to do it. I don't think hot air would work too well with a chip like this, where you can't be sure all the legs are actually sitting flat on the board. Well, you can see straight away, I'm just getting solder bridges. That means I have too much solder on the iron. I might be able to remove them without braid. Maybe I need braid. Let's have a go. So I'm just reheating a little bit without any solder on. I'll clean the end of the iron. Or at least I think I have. Yeah. So I'll take some of that solder, move it a bit further down. In fact, I'm using this as a little reservoir of solder for the other pins. Extra flux will help if it's doing that. Okay. Okay, the chip is mostly down now. You'll see I'm not adding solder because there seems to be enough on the chip already. That's probably why I ended with some bridges to start with, but the pads and the pins seem to have enough. And if I find any that didn't solder, I can come back and fix them a bit later. And the same with any of these solder bridges that I have. Okay, so that's mostly down. There are a few bridges here and there, so what I'll do is I will clean all this off with some ISO and then see what we have left. There's definitely one there, one there. They're going to need a bit of braid. Actually, before I put the ISO, I'll just try and clean them a bit anyway. Okay, I'm just looking if I can see any more that look like they're not soldered. At this point now I can usually just slide the edge of this big tip up so it's touching the pin and just flow some solder onto it. Okay, you see what I'm doing? I'm just touching the pad and touching the pin, not going onto the pin as such. Might need a bit of extra solder there and here. There's no longer enough excess solder here, you can see, to cause any bridges. Again, I might need a little bit more just there. One more solder bridge I see. Here. Okay. This is the awkward side because this is in the way, but as I said, the first place I should have unsoldered it to start off with. That one looks okay. Those I'm not sure. Okay, now we'll clean it up and now let's have a look to see what we have. This is where now you can figure out if you have any pins that are not soldered down or you have any bridges. You can see a lot more clearly now. I can touch the pin. Still a bit wet actually, let's dry this off. So I can push on these pins with the end of the tweezers. These are actually stuck down, although they don't look like they're well coated with solder. Probably better just waiting for the rest of the ISO to dry out. It's coming from under the chip. I'm just putting pressure against each one to see if it is actually stuck down or not. See, that one isn't. Okay, so we have one there that isn't. Soon deal with that. We'll push it down and we'll just get a bit of solder in from the end of it. Okay, this is where we make us another solder bridge. Nothing much you can do about that, just clean it up if you do and go again. Just a tiny touch of solder on the soldering iron, that's all you need, and then slide in from this direction again. So I'm just sliding up until it touches the actual pins, okay? See if that's got it. Well, I can see straight away I have a couple of solder bridges now. Sort them out if we can. See if it'll just draw the solder out. Yeah, they're coming out, you can see. and we'll do the final inspection with the Andon Star USB microscope. It gives a better image on the screen for you guys, but because there's no perspective, no depth perception, I can't solder under it, but it's a fantastic tool. It looks like we have one here that may not be soldered, but I did test them all. We can double check. That one, but I'm pushing against it, is stuck down. That one is stuck down. This one, yeah, they're all stuck down. Okay, maybe not the tidiest soldering job, but it is soldered well. Okay, I have checked all these. I'm just looking for solder bridges, really, anything I might have missed. Don't see anything. Good thing with this microscope, it's easier to get the thing at an angle and look down the edge. This is where you might find something nasty that you didn't realise, but that's okay. Down this side, yeah, you can see that's okay. This side, yeah, that's fine. And the last side here, let's have a look. Yeah, that's okay. Let's see if this actually works. Well, let's see. I suppose the quickest test is just if it powers up or not now. And it's bleeping. It's bleeping, yeah. The fan isn't working on the CPU. In fact, it's really stiff. But I think we can power this up long enough to see whether we get a picture or not. You can see the monitor there. Let's see. It's no longer bleeping. I put the RAM in. Oh, yeah, one blip, blue light on the monitor, and we have a picture. I won't run this long as the heatsink is on, but the cooling fan isn't working. It's not overly hot, but you can see it there. Okay, so that's a good one, guys. Okay, I hope you enjoyed that one. It's good to see something else saved from the landfill, especially when it's a nice retro motherboard like this one. These are definitely worth repairing. They have a decent value now, and the value will increase, especially when you can use a part like that, which was a pull anyway. That should give you some idea of how to change an SIO, or possibly how not to change an SIO, but you cannot detract from the fact that it did work, yeah? And what's more important than that? Okay, hope you enjoyed it, and I'll see you all soon on another Learn Electronics Repair video. Ciao for now, guys.